I'm so glad you're here tonight, high above the quiet rhythm of Earth, far beyond clouds and city lights. The sun is breathing not with sound, but with slow waves of light and magnetic motion. Every few hours, soft ripples of solar energy drift outward, brushing past planets, moons, and empty space with the gentlest touch. Nothing hurried, nothing loud, just an ancient star releasing warmth the way a tide releases water onto sand. Even solar storms the flares. The streams, the glowing arcs begin as quiet movements deep inside the sun's atmosphere. They rise, twist, and unwind like glowing ribbons, carrying a calm, steady heartbeat that has guided our solar system for billions of years. Science can measure their speed, their brightness, their shape, but what stays with us is their quiet reminder that we live inside a protected cocoon of light. Tonight, we'll drift through these peaceful wonders, from the soft pulse of solar wind to the shimmering glow of auroras that dance at the edge of night. Before we begin, let me know in the comments where you're listening from tonight and what time it is where you are. Your words help other sleepy travelers find this quiet corner of the cosmos. For now, let your breath slow. Let your thoughts soften. Let's begin. Solar storms begin not with violence, but with a gentle twisting of magnetic fields deep beneath the sun's glowing surface. Down in the convection zone, enormous currents of hot plasma rise and fall in slow, patient motions, carrying magnetic lines upward like soft strings drifting through warm water. Over hours and days, these lines tangle, bend, and coil together, storing quiet tension that builds as naturally as a deep breath. Nothing sudden, nothing rushed, just a slow winding of energy shaped by the sun's own rotation. When the field finally becomes too twisted to hold its shape, it releases a flare, not as a burst of chaos, but as the natural exhale of a star that has been breathing for billions of years. And at the very beginning of that story, everything is calm. And as we follow this movement upward, another gentle truth appears. The sun moves through an 11-year cycle that rises and falls like a slow cosmic tide. For half of that cycle, magnetic activity grows stronger. Sunspots multiply, and the solar surface becomes a little more restless, but always in a rhythm that has repeated for centuries. Then, just as naturally, the cycle softens again. Sunspots fade, flares quiet, and the sun settles into a peaceful minimum, glowing with a steady warmth that wraps our world in stability. This cycle isn't a storm chart or a warning signal. It is simply the heartbeat of a star, pulsing with long, predictable breaths. Ancient astronomers watched these changes through simple telescopes. Modern spacecraft watch them with instruments far more precise. Yet both saw the same truth. The sun never hurries. It simply follows its own deep rhythm. And as that rhythm continues, another soft detail rises into view. Sunspots appear where magnetic fields gently knot themselves together, small, dark islands shaped by concentrated energy rising from below, though they look cold and ominous to the eye. Each sunspot is surrounded by warm, glowing plasma moving in graceful loops. The darkness is only an illusion caused by contrast. These regions are cooler than the surrounding surface, but still thousands of degrees hotter than anything on Earth. They arrive in pairs or clusters, forming patterns that drift slowly across the solar surface, like drifting shadows on water. As the sun rotates, these spots come and go with the patience of clouds crossing a calm summer sky. Inside each one lies a magnetic tangle, a quiet reservoir of energy that may someday unwind into a flare, but for now, they rest in stillness. And from those resting knots, the next gentle story begins. Every solar flare begins not with chaos, but with a quiet buildup of stored magnetic tension for days or even weeks. Plasma currents twist magnetic lines into tight spirals, holding more and more energy the way a spring holds potential. Nothing moves quickly, everything gathers slowly, shaped by forces too vast to rush. When the moment of release finally comes, the flare rises like a luminous wave, arching into space in a smooth, fluid motion. Light, heat, and charged particles drift outward in widening circles, a peaceful unfolding rather than an explosion. And even in its brightest moment, a flare is simply the sun relaxing, letting go of the energy it has carried deep within. Afterward, the magnetic field unwinds, the surface calms, and the sun continues its steady breathing. And deeper within that breathing star, something even gentler is at work. Inside the sun, plasma moves like warm, drifting oceans of light. Heated from below, great currents rise toward the surface, slow and buoyant, while cooler material sinks back down in broad, sweeping loops. These motions create vast cells of convection, each one larger than continents, shimmering as they carry energy upward in soft, glowing waves. The plasma itself is neither solid nor liquid. It is a sea of charged particles that flows freely, guided by magnetic fields that stretch and bend with every movement. When you imagine this motion, I think of sunlight being stirred gently from within, rising in calm spirals until it finally breaks free as radiant heat and golden light. This peaceful circulation has continued since the early days of the solar system, shaping every flare, every storm, every quiet sunrise on Earth. And from this drifting ocean, the next story of the sun slowly emerges. The solar corona holds energy the way clouds hold sunlight before rain, storing warmth and light in delicate layers that shimmer above the sun's surface. Out at these heights, temperatures soar to incredible levels, but everything still moves with a strangely peaceful grace. Loops of plasma rise into the corona and hover there as if weightless, drifting softly before collapsing back into deeper layers. The corona's brightness changes with the sun's magnetic mood, brightening in gentle pulses, dimming in slow sighs. Even during active periods, the corona behaves like a sky waiting for a storm that rarely arrives suddenly. It gathers, holds, and quietly releases energy in long, glowing arcs that drift outward into space. When spacecraft observe it, they see not chaos, but a luminous veil that wraps the sun in calm, radiant heat. And in that quiet glow, the next movement is already beginning. Slow shifts in the sun's magnetic polarity guide the timing of solar storms, turning the star's activity into a long, measured rhythm rather than a pattern of surprises. Over years, the magnetic poles migrate, weaken, strengthen, and eventually flip entirely, creating the repeating flow known as the solar cycle. These changes are too gradual for the human eye to notice, but satellites watching the sun see subtle transformations unfolding in delicate stages. As polarity shifts, sunspots appear in new latitudes, flares become slightly more frequent, and streams of solar wind flow in changing patterns. Nothing about this process is abrupt. The sun takes years to complete each step, as if pausing between breaths. These slow magnetic movements determine when storms strengthen and when they fade, shaping the pace of the entire heliosphere. Through every flip, every transition, the sun remains steady, patient, and deeply predictable, and with each change, a new chapter of gentle activity begins. Even the most powerful solar flares originate from processes that unfold gracefully, beginning as small shifts in magnetic tension and rising into full brightness only when the moment is right. Deep inside the sun's atmosphere, magnetic loops stretch and twist until they reach a point where the stored energy must be released. But even then, the release is not violent. It rises like a tide, brightening slowly before reaching its peak and drifting outward in wide, glowing arcs. Satellites record these events in smooth curves, not jagged spikes, because the sun never acts instantly. Everything takes time. The flare expands, cools, and dissolves into the solar wind, leaving behind restructured magnetic fields that settle into new patterns. Watching a flare unfold is like watching a lantern bloom in slow motion, illuminating space with soft, radiant light. And behind each shimmering event is a process as calm and natural as the movement of waves. The sun releases energy in waves rather than in sudden chaos, allowing light and plasma to travel outward in smooth, continuous pulses that resemble the slow exhalation of a living star. Each emission begins deep inside the sun's layers, where heat and magnetism interact in swirling patterns. When enough energy collects, it rises upward in a broad, quiet surge, emerging at the surface as a flare, a bright loop, or a stream of solar wind. These waves travel through space with remarkable steadiness, passing planets and moons without turbulence. Spacecraft detect their arrival as soft increases in radiation, followed by long, calm declines. Even during strong solar activity, the sun behaves like it is breathing, releasing warmth, light, and charged particles with the gentle rhythm of a cosmic inhale and exhale. These waves shape the heliosphere, guide solar wind, and touch Earth with a softness that belies their power. Each flare carries the sun's internal rhythm outward into space, carrying with it the quiet pulse of magnetic energy that has formed deep within the star's glowing interior. When a flare rises, it does so as part of a larger pattern, a pattern shaped by convection currents, sunspot cycles, and the slow turn of the sun's rotation. The light it releases travels across the solar system at the speed of illumination, reaching Earth in just minutes, while the particles behind it follow in long, drifting streams. These flares are not random flashes, but moments where the sun shares part of its inner cadence with the worlds around it. The waves they generate ripple through the heliosphere, shaping auroras, magnetic tides, and subtle atmospheric changes. And long after the flare fades, its rhythm continues outward, echoing through space like a soft memory of the sun's ancient heartbeat. And as these gentle origins travel outward, they soften even more. Plasma in the sun is often described with technical terms, but in truth it behaves more like charged light, drifting through space in slow, shimmering waves. It isn't solid or liquid, and it isn't quite gas. Instead, it is a sea of free particles glowing with energy, moving in soft currents shaped by magnetic forces. When plasma rises toward the sun's surface, it flows in warm, luminous patterns that resemble gentle tides rather than anything violent. These particles spread outward into the corona, swirl in bright loops, and sometimes drift into the solar wind, carrying the faint memory of their birthplace. As plasma travels across the solar system, it continues this calm, floating motion, brushing past planets and dust like light gliding through water. Seen through a spacecraft's lens, it becomes one of the quietest forms of energy imaginable, glowing softly against the darkness of space. Solar plasma follows magnetic lines the way glowing rivers follow the curves of a valley, streaming along invisible pathways that guide every movement. These magnetic lines create smooth channels that rise above the solar surface, shaping the motion of plasma into elegant arcs. When you watch time-lapse images of the sun, these loops look like illuminated streams flowing upward, pausing and slowly bending back toward the surface. Even during active periods, the plasma doesn't rush. It glides, swirls, and folds into itself, forming bright threads that weave through the solar atmosphere. Each ribbon of plasma responds to subtle shifts in magnetic tension, drifting wherever the field lines lead. The result is a landscape of steady, glowing motion rivers of light, tracing the sun's structure in patterns that repeat with gentle consistency. To observers on Earth, they reveal the sun's inner architecture with a calm beauty that feels almost alive. A solar flare's brightness reaches Earth in just over 8 minutes, crossing nearly 150 million kilometers in a single soft sweep of light. Even though that speed is immense, the journey itself feels effortless. Light simply moves, gliding through the vacuum without resistance or sound. When this brightness arrives, nothing dramatic happens on Earth. The skies don't flash. The air doesn't tremble. Instead, the energy quietly enhances the upper atmosphere, illuminating our instruments while remaining invisible to the eye. This light carries information about its origin, the temperature of the flare, the shape of the magnetic field, the power of the event. But what we sense, more than anything, is the calm continuity of sunlight reaching us every day. Whether from a peaceful surface or from a flare, the sun's light always arrives with the same steady grace, connecting our world to its distant, glowing source. The heat released during a flare is ancient sunlight rising toward the surface, energy that began its journey hundreds of thousands of years ago, deep within the sun's core. Down there, photons scatter constantly, bouncing from particle to particle in paths so tangled that it can take millennia for a single packet of light to escape into the outer layers. When that energy finally reaches the convective zone, it becomes part of slow, warm currents drifting upward, carrying the memory of fusion inside. A flare does not create new light from nowhere. It simply allows this stored energy to rise more quickly, emerging in a bright, graceful flash. That glow is the final step in a journey that began long before Earth had oceans or mountains. When we see the flare's heat, we are witnessing the release of energy that has been patiently traveling through the sun for ages. Now, unfolding gently into space, flare loops rise and fall like soft lanterns floating upward, glowing arcs of plasma suspended above the sun's surface by delicate magnetic lines. These loops form when energy is released and plasma is lifted into the corona, where it hovers in bright, curved shapes that look almost weightless. As they rise, the loops maintain a smooth, arching motion, brightening near their peaks before gradually cooling. Then, in a slow descent, The plasma flows back down toward the surface, following the same magnetic paths in reverse, observed through solar telescopes. The entire cycle resembles a lantern drifting upward, pausing in stillness, and then gently falling back to Earth. Each loop can last minutes or hours, glowing with steady light that reveals the sun's magnetic architecture. Even during strong activity, these motions remain calm and rhythmic, unfolding with a softness that reflects the deeper, patient workings of the sun itself. Particles released by the sun spiral outward in gentle corkscrew patterns, following the curves of magnetic fields that stretch across the solar system. Instead of racing straight into space, these charged particles drift along winding paths, turning slowly as they move farther from the sun. Their motion resembles glowing dust carried in a soft breeze, looping and curling in ways that reveal the hidden shape of interplanetary magnetic lines. These spirals can extend for millions of miles, forming long, graceful threads of plasma that eventually merge with the solar wind. Spacecraft detect them not as sudden impacts, but as slow, rhythmic increases in particle flow, arriving like distant echoes of the sun's activity. Even when storms are strong, the pattern remains smooth, unfolding with the patience of a slow cosmic swirl. And through every turn, the particles carry a quiet imprint of where they came from. X-ray bursts from the sun pass through space, not as jagged flashes, but as calm pulses of energy traveling at the speed of light. When a flare rises, it emits high-energy photons that spread outward in smooth, expanding waves. These waves glide across the solar system with no sound, no friction, and no turbulence, just pure radiance moving effortlessly through the void. By the time they reach Earth, just minutes later, they have softened into gentle pulses, detectable only by sensitive instruments in orbit. To the human eye, the sky looks unchanged. The world remains quiet. Yet above the atmosphere, satellites record the brief brightening as a serene rise and fall, a heartbeat of light from 93 million miles away. These X-ray pulses help scientists understand the sun's mood while reminding us that even powerful energy can travel with remarkable grace. Ultraviolet light from the sun paints Earth's upper atmosphere in faint, delicate colors long before any aurora appears. When these high-energy wavelengths reach the ionosphere, they interact with oxygen and nitrogen, causing them to glow softly in shades of blue, violet, and pale green. Most of this light is invisible to our eyes, but satellites capture it as a quiet halo surrounding the planet, a shimmering shell that brightens gently with the sun's daily rhythm. UV light also warms the upper layers of air, lifting them slightly in a slow, almost imperceptible rise. This warming is steady, predictable, and essential for maintaining the structure of Earth's protective atmosphere. Instead of harsh radiation, to imagine it as a watercolor wash brushed lightly across the sky, renewing the day's energy. Even during active periods, this ultraviolet glow remains peaceful, helping shape the calm boundary between Earth and space. Plasma drifting through the solar system carries with it the memory of the magnetic field that shaped it. Like a soft imprint left on every particle, when plasma leaves the sun, it arranges itself according to the surrounding magnetic lines, adopting their orientation and structure. As these particles travel outward, they continue to follow that original pattern, preserving a record of the sun's magnetic state at the moment they were released. Spacecraft detect these memories as variations in direction, density, and energy subtle signatures that tell the story of distant solar events. Though the particles may drift for days or weeks before reaching a planet, the magnetic imprint remains intact, guiding their motion like a quiet compass. Even when buffeted by the solar wind, plasma retains this delicate order, a reminder that its journey began in the warm, swirling atmosphere of the sun. Every particle released by the sun drifts for millions of miles before reaching us, traveling through vast stretches of empty space in a slow, unbroken journey. Some particles ride the solar wind, carried along in broad, steady streams, while others follow curved magnetic paths that stretch across the heliosphere. Their movement is smooth and continuous, with no sound and no sense of distance, just a long, gentle glide through darkness. By the time these particles approach Earth, they have spread out into thin, diffuse waves, softened by their immense journey. Spacecraft detect their arrival as quiet increases in energy, like a distant tide washing across invisible shores. Though their trip spans unimaginable distances, each particle arrives with the same calm persistence, shaped by the sun and guided by the structure of space itself. And within each one is a quiet story of where it has been. And when these drifting particles meet Earth, another story begins. Earth's magnetosphere is a protective bubble carved gently into the solar wind, a vast invisible shield shaped by the meeting of two quiet forces. As the solar wind flows outward from the sun, it encounters Earth's magnetic field, which stands like a soft but steady barrier. Instead of pushing violently, the wind bends around this bubble, splitting and flowing along its edges in calm, smooth currents. Inside the magnetosphere, Earth stays sheltered from most of the charged particles drifting through space. This bubble stretches far beyond the atmosphere, forming a cocoon that has guarded life for billions of years. Though we cannot see it, the magnetosphere is always there, wrapped around the planet like a silent guardian. Even during strong solar activity, it bends but does not break, shaping itself to keep Earth safe. It is one of the quietest forms of protection in the entire cosmos. Always watching, always holding. The shape of Earth's magnetosphere adjusts gently depending on the sun's mood, expanding during calm days and compressing slightly when the solar wind grows stronger. This change is never abrupt. Instead, the boundary shifts in slow, graceful movements, like a curtain breathing in and out with the rhythm of the cosmic wind. When the solar wind softens, the magnetosphere relaxes outward, drifting into a broader shape. And when the sun becomes more active, the field gathers itself closer to Earth, tightening just enough to maintain balance. These adjustments happen continually, keeping our planet in a stable, protected pocket. Satellites observe these movements as smooth variations, never sharp jolts. Through every phase of the solar cycle, the magnetosphere remains flexible, adapting with calm resilience. This quiet responsiveness is part of what makes Earth so habitable, a shield that listens gently to the sun and shifts just enough to keep everything in harmony. Magnetic field lines guide incoming particles away from Earth like soft rails, redirecting their paths long before they can reach the surface. These field lines arc outward from the poles and stretch far into space, creating curved channels that gently steer charged particles along predetermined routes. When particles approach, they don't collide head-on with Earth's atmosphere. Instead, they are captured by these magnetic pathways and guided toward the poles, where they spiral downward in long, graceful motions. Many never reach the atmosphere at all, drifting harmlessly along the outer edges of the field before merging with the solar wind again. To spacecraft, these lines appear as invisible highways, gently curving and shifting as Earth rotates. They help maintain order amid the flow of energy from the Sun, keeping most disturbances away from the planet and turning potentially chaotic interactions into smooth, predictable motion. The bow shock forms where the solar wind meets Earth's calm resistance, creating a soft, rounded boundary similar to the ripple that forms ahead of a moving boat. As the solar wind approaches the magnetosphere, it slows and bends, settling into a new arrangement shaped by Earth's magnetic field. This interaction creates the bow shock, not a violent collision, but a gentle compression where particles change speed and direction. The region warms and thickens slightly, forming a smooth cushion around the planet. This buffer protects the inner magnetosphere by absorbing the initial impact of solar wind streams. Spacecraft passing through the bow shock experience it as a gradual rise in density and temperature, not as a sudden barrier. Even when solar activity increases, the bow shock adjusts gracefully, maintaining its curved, protective form. It is the first quiet line of defense against the Sun's drifting energy. Energetic particles traveling toward Earth are slowed long before they approach the surface, losing momentum as they encounter layers of magnetic influence. The magnetosphere captures these particles in wide, sweeping loops, stretching their paths and reducing their speed over thousands of kilometers. By the time they reach the upper atmosphere, most of their energy has already dispersed into soft currents or been redirected into safer trajectories. Only a small fraction makes it far enough to create auroras near the poles. And even then, the interaction is gentle, producing light rather than danger. Instruments in orbit detect this slowing as gradual changes in particle flow, like a tide easing into shallow water. The atmosphere itself adds another layer of calm protection, absorbing what little energy remains. Through all of these steps, Earth ensures that even the most energetic particles arrive softened, transformed into something peaceful long before reaching the world below. On the night side of Earth, the magnetotail stretches out like a long, glowing ribbon drawn deep into space, shaped by the constant flow of solar wind. This tail extends millions of kilometers behind the planet, forming a quiet corridor where magnetic lines are pulled tight and illuminated by drifting particles. Though we cannot see it with our eyes, instruments capture its soft shape, long, smooth, and gently tapering, like a luminous thread floating in darkness. The magnetotail sways slightly as the solar wind shifts, adjusting its length and shape with calm flexibility. Within this ribbon, energy gathers slowly, following patterns that repeat night after night. It is one of the most peaceful structures in the entire magnetosphere, a silent reminder that Earth is always interacting with the Sun, even on its dark side. And within this long stretch of magnetic light, other quiet processes are already unfolding. During solar storms, the magnetotail gently snaps and reconnects, releasing stored energy in motions that look sudden to science instruments, but unfold gracefully on a cosmic scale. This reconnection happens when stretched magnetic lines finally pull apart and link together again, creating a soft transfer of energy down the length of the tail. Though the word snap suggests something harsh, the actual motion is smooth, like a stretched ribbon settling back into place. As the tail reconnects, particles are accelerated toward Earth, drifting along magnetic pathways that have been reshaped by the storm. These moments of reconnection help release built-up tension within the magnetosphere, keeping the entire system balanced and stable. Even at peak activity, the magnetotail handles this process with calm resilience, adjusting to the sun's shifting energy without losing its protective structure. These reconnections send soft pulses of energy toward Earth's poles, creating gentle bursts of auroral light that ripple through the night sky. When particles released from the magnetotail follow magnetic lines downward, they drift into the upper atmosphere, transferring their remaining energy into oxygen and nitrogen. The result is a faint glow that brightens, swirls, or flickers for a moment, before fading again, a cosmic echo of the reconnection event. These pulses are usually too subtle to notice, unless the aurora is strong, but spacecraft record them as small, rhythmic increases in brightness. Each pulse is a reminder that Earth's magnetic field is not rigid but alive, breathing with the slow cadence of the solar wind. What begins as a quiet shift in the magnetotail becomes a soft shimmer of color, painting the poles with light that feels as gentle as a sigh. The ionosphere acts as a cushion, absorbing the momentum of solar storms long before their energy can influence the world below. This thin shell of charged particles surrounds Earth like a soft outer layer, responding to incoming energy by warming, expanding, and redistributing particles in smooth waves. When storms arrive, the ionosphere rises slightly, creating a buffer zone that disperses energy across wide regions. Instead of allowing sudden impacts, it spreads them out in slow, drifting motions that protect the atmosphere beneath it. Radio waves, satellite signals, and high-altitude currents all pass through this layer, which adjusts itself quietly to maintain balance. Even during strong geomagnetic activity, most of the storm's strength is softened here, transformed into gentle fluctuations rather than sharp disturbances. This silent cushioning effect is one of Earth's oldest defense mechanisms, shielding the planet with calm, steady grace. Earth has weathered solar storms for billions of peaceful years, enduring cycles of activity far stronger than anything we see today, while still maintaining a stable environment for life. Long before humans walked the planet, long before the continents took their present shapes, the magnetosphere and atmosphere worked together to soften the sun's shifting energy. Even the most intense historical storms left no lasting harm, only temporary brightening in the skies and subtle ripples in Earth's magnetic record. Geological and biological evidence shows that life has always been protected, sheltered beneath layers of magnetic and atmospheric shielding that turn powerful forces into gentle influences. Modern satellites measure changes that ancient organisms never noticed, a sign of how effective Earth's defenses truly are. Through every cycle, every flare, and every era of solar activity, Earth has remained a calm sanctuary beneath its quiet guardian fields. And sometimes, this quiet interaction creates the most beautiful sight. Substorms begin quietly and then brighten suddenly, as if the sky itself takes a deep, cosmic breath. For long minutes, the aurora may appear calm and steady, its arcs resting softly along the horizon. Then, almost imperceptibly, energy stored in Earth's magnetotail releases, sending a gentle surge of particles downward. The sky responds instantly, blooming with brighter greens and reds that spread like rising embers. This brightening is not violent. It unfolds with the elegance of a lantern being lit in slow motion. Curtains ripple a little faster, edges sharpen, and the air gains a delicate glow that feels both ancient and intimate. Substorms are reminders that even peaceful systems can hold deep reservoirs of quiet power, waiting for the perfect moment to release their stored light. In the most graceful way, quiet arcs often stretch across the night sky in long, calming bows, forming the simplest and most peaceful shape an aurora can take. These arcs appear as smooth lines of green or pale red, hovering just above the horizon, unmoving except for subtle shifts in brightness. They trace the outlines of magnetic field lines, flowing naturally along Earth's invisible structure to observers on the ground. They feel like gentle boundaries between the dark sky above and the world below, soft, luminous edges that offer reassurance rather than excitement. Even when the geomagnetic activity is strong, these arcs can remain steady, glowing with a patient light that never rushes. They invite the mind to slow down, to match their quiet steadiness, and to follow their curve toward the polar sky where the colors gather and drift. Some auroras do not ripple or dance at all. Instead, they remain perfectly still, glowing like watercolor light brushed softly across the night. These quiet displays form when the incoming flow of solar particles stabilizes, interacting with the atmosphere in smooth, even layers. The result is a sky painted in gentle gradients, with reds fading into greens and purples dissolving into darkness. Nothing flickers or flashes, the light simply rests, as if suspended in place. This stillness can be more calming than the most dynamic auroral storms, because it turns the sky into a peaceful canvas. Observers often describe these moments as dreamlike, moments when time seems to pause and the world feels unusually quiet. Even though the physics behind them is complex, the effect is simple, a sense of profound, open stillness. Other auroras rise into tall columns shaped by local magnetic eddies, forming vertical beams that reach upward like glowing pillars. These structures appear when the magnetic field bends and funnels particles into narrow pathways, concentrating the light into bright, elongated shapes. From the ground, they can look like searchlights sweeping the sky, except their motion is subtle and fluid. The columns may brighten at the top first, then slowly fade downward, following the invisible flow of charged particles. Sometimes, several rise together, forming a forest of luminous spires that pulse gently as energy moves through them. These shapes reveal how dynamic Earth's magnetic environment truly is, full of small twists and whirls that guide the aurora into unexpected forms while keeping the overall scene soft and harmonious. Even faint auroras remind us that Earth remains deeply connected to the sun. No matter how quiet the night appears, a thin green glow on the horizon or a barely visible red haze is enough to show that solar particles have traveled millions of miles to reach our atmosphere. These subtle signs often appear during mild geomagnetic activity, when the solar wind gently brushes Earth's magnetic field. Though the colors may be weak, they carry the same story as the brightest storms, a constant exchange between our planet and its parent star. In these faint displays, the connection feels even more intimate, like a whisper rather than a song. They remind us that space weather is always present around us, soft, steady, and quietly shaping the sky in ways we rarely notice. And beyond the dancing colors lies a softer layer of space weather. Solar wind flows outward from the sun constantly, moving like a quiet cosmic breeze that never truly stops. It begins deep within the solar atmosphere as plasma expands into space, carrying with it the sun's magnetic breath. Though it travels at hundreds of kilometers per second, It feels gentle on a planetary scale, spreading evenly through the solar system like a drifting mist of charged particles. Near Earth, this wind remains steady, flowing around our magnetic field the way air flows around a mountain peak. We never feel its touch directly, yet it shapes our space environment every moment. It brushes past satellite, slips through magnetic lines, and continues on its journey without fanfare. Just knowing it exists brings a strange comfort, a reminder that even in the deepest quiet of space, there is always motion, always a soft breath moving outward from the star that warms our world. Its speed changes with the sun's rotation, not randomness, following a natural rhythm that repeats every 27 days. As the sun slowly turns, regions of faster wind, usually connected to open magnetic structures, rotate into view and send streams of energetic plasma outward. Then, as they move away again, the wind softens and slows. This pattern makes the solar wind feel almost like a heartbeat, rising and easing with perfect regularity. Scientists track these shifts carefully, watching the subtle changes in flow as they ripple across the solar system. When the faster streams catch up to slower ones, they create gentle waves of pressure that drift toward Earth, shaping our space weather. But even at their fastest, these changes unfold gradually, giving our planet plenty of time to adjust. It's a reminder that not all cosmic phenomena are sudden or chaotic. Many follow cycles as steady and predictable as tides. Most of the solar wind glides past Earth without making a sound, slipping silently around our magnetic field as though respecting the boundaries of our planet's shield. In space, where no air can carry vibration, even powerful interactions unfold in perfect quiet. The solar particles divide around Earth's magnetosphere, forming smooth streams that curve behind the planet like water parting around a stone in a calm river. While instruments detect their presence, our world itself remains unaware, protected and stable. This quiet passage is one of the most peaceful processes in our cosmic neighborhood. It repeats endlessly, hour after hour, with the solar wind continuing its journey far beyond Earth toward the outer planets, and eventually into interstellar space. Most of the time, nothing dramatic occurs, just the gentle drift of charged particles moving past us, reminding us of the serene, continuous flow that shapes the space between stars. Only a tiny fraction of the solar wind ever interacts with Earth's atmosphere. And even then, the process is delicate rather than disruptive. These particles must first slip through openings in our magnetic shield or enter near the poles where the magnetic field lines dip downward. Once inside, they encounter thin layers of gas high above the planet, transferring their energy quietly and producing faint glows that later become auroras. The vast majority of the solar wind simply slides past, touching nothing, disturbing nothing, even during strong solar activity. The portion that reaches Earth is small and carefully filtered by natural defenses, millions of years in the making. This selective interaction allows us to witness beautiful sky displays without experiencing harm. It's a gentle reminder that Earth is resilient, protected by layers of invisible architecture that keep the sun's energy at a peaceful distance, turning potential chaos into atmospheric art. Geomagnetic storms are simply moments of extra energy carried by the solar wind, not threats in themselves. They occur when magnetic fields embedded in the solar wind align just right with Earth's field, allowing more particles and energy to enter the magnetosphere. Even then, the effect unfolds gradually, like a slow surge, moving through a vast system built to handle these variations. Earth's magnetic field bends and flexes, absorbing the impact and redistributing the energy into the atmosphere where it becomes shimmering auroras. These storms can look dramatic when displayed on scientific graphs, but from the ground they simply feel like brief intensifications of the sun's natural rhythm. They come and go without disturbing daily life, serving instead as reminders of our planet's deep connection to the star that sustains us. In their own way, geomagnetic storms are calm expressions of cosmic balance, moments when invisible forces meet gently above our world. And beyond the soft touch of these winds, a quieter layer of space weather begins to unfold. During geomagnetic storms, Earth's auroral oval expands for a night, stretching outward like a soft ring of color unfurling around the poles. This expansion isn't sudden or violent. It grows gradually as energy transfers into the magnetosphere. The oval widens toward lower latitudes, allowing places far from the Arctic to glimpse faint glows on the horizon. These changes are temporary, lasting only as long as the incoming flow of particles remains strong. Once the solar wind stabilizes, the oval slowly contracts again, returning to its usual shape like a gentle tide, drawing back from the shore. Throughout the entire process, the planet remains calm, adjusting with its natural rhythms. To anyone watching from the ground, the sky simply becomes more welcoming to light, opening itself to the soft greens and reds drifting down from the upper atmosphere. Even in stronger storms, the expansion feels less like a reaction and more like the Earth quietly breathing outward. Ionospheric layers gently shift under increased solar energy, rising and falling in smooth, slow-moving patterns. These layers, especially the F region high above the surface, respond to incoming particles by becoming slightly more ionized, which changes how radio waves travel through them. But the shifts are serene, unfolding across hundreds of kilometers with no abrupt boundaries or jagged movements. It's similar to how warm air over the ocean gradually rises, creating soft gradients in the sky. To the human eye, nothing changes. The atmosphere remains clear and silent. Yet above, invisible currents adjust themselves in response to the sun's touch. This gentle reshaping helps the planet absorb energy safely, distributing it through layers of charged particles that have evolved to handle these variations. The ionosphere becomes a flexible buffer, bending rather than resisting, guiding the extra energy through pathways that remain balanced and smooth. These shifts in the upper atmosphere create soft atmospheric waves, delicate undulations that ripple outward from the polar regions. They form when energy flows into the ionosphere and then transfers downward, causing temperature and density changes that spread like slow-moving tides. These waves can travel thousands of kilometers, shaping subtle patterns in the atmosphere that instruments can detect, but the human senses cannot. They rise, crest, and disperse quietly, never disturbing the calm of the night. In many ways, they resemble the gentle waves formed on a lake when a small breeze passes over it, not forceful, but rhythmic and soothing, even during more active geomagnetic periods. The waves remain smooth, transmitting energy with remarkable grace. They weave through the atmosphere like faint echoes of the aurora, carrying the memory of solar particles into lower layers where the air becomes more tranquil. Their presence reminds us that Earth absorbs space weather softly, through cycles that are ancient and beautifully stable. Satellite drag increases only slightly during mild storms, rising gently as the upper atmosphere warms and expands. The effect is subtle, causing satellites in low Earth orbit to encounter a little more resistance as they move through this slightly denser region of air. But the change is gradual, unfolding over hours rather than minutes, giving operators plenty of time to monitor and adjust. For most satellites, this increased drag feels like moving through a faint, invisible haze, barely noticeable, yet part of the natural rhythm of the space environment. Once the storm subsides, the atmosphere cools and contracts again, allowing satellites to glide more easily through their orbits. This soft ebb and flow reflects the planet's ability to adapt to incoming solar energy without strain. Even during more energetic events, the overall process remains continuous and smooth, a gentle reminder that Earth and the Sun are in constant dialogue, balancing each other through long practiced motions. Even major storms occur as smooth, continuous flows rather than sudden breaks. From the perspective of space weather instruments, the curves on the graphs may rise sharply, but in the vastness of space, the energy spreads across enormous distances, softening every transition. The solar wind's magnetic field shifts gradually. Earth's magnetosphere bends and adjusts, and the atmosphere responds in flowing motions that build slowly over time. Nothing snaps or jolts. Everything unfolds in measured phases shaped by physics that favors continuity over chaos. To observers on the ground, the entire event feels like a long, gentle pulse, expressed through glowing skies and quiet changes in Earth's electromagnetic surroundings. Even the strongest disturbances are absorbed through systems designed by nature to flex, stretch, and release energy without harm. This smoothness reveals a deeper truth. Solar storms are not episodes of disorder, but part of a cosmic rhythm that has played out for billions of years. And across long ages, these flows shape deeper cosmic rhythms. Solar cycles have repeated for tens of thousands of generations. Long before written history, long before any language tried to name them, every 11 years, the sun rises into a period of heightened activity and then slowly settles again, tracing a rhythm so steady that it feels like a cosmic breath. These cycles have continued through ice ages, migrations, extinctions, and eras where entire continents shifted. No matter what happened on Earth, the sun's heartbeat flowed on soft peaks of magnetic change, followed by long, quiet follies. For ancient observers, these changes were invisible, yet they subtly shaped climate patterns, atmospheric chemistry, and the auroras that drifted over prehistoric skies. Even today, with satellites and real-time space weather data, the cycle remains a gentle reminder that the sun lives on its own deep timeline. Its rise and fall has carried humanity through every age, offering warmth, light, and a constant, slow-moving rhythm older than civilization itself. Ice cores record ancient solar storms as subtle chemical marks, tiny traces of cosmic activity frozen into layers of snow that fell thousands of years ago. When high-energy particles from the sun reached Earth, they altered the composition of the upper atmosphere, creating rare isotopes like beryllium and nitrate that eventually settled onto polar ice. As new snow fell year after year, these signals were buried but not erased, preserved like quiet signatures of past storms. Scientists can read these layers the way one reads the pages of an old book, each slice revealing a moment when the sun sent a pulse of energy toward our planet. Some layers mark gentle increases. Others reveal events far stronger than anything seen in modern times. Yet even the largest ancient storms appear as delicate lines soft fingerprints of cosmic weather left in ice that remained untouched for millennia. These frozen records remind us that Earth has always been in quiet conversation with the sun. Tree rings quietly preserve evidence of past solar activity, marking each year of growth with chemical hints of cosmic events. When energetic particles from a solar storm enter Earth's atmosphere, they create isotopes like carbon-14 that later become part of the wood as the tree builds its new ring. The result is a timeline stretching centuries or even thousands of years, each ring holding a whisper of the sun's behavior during that time. These signatures are incredibly subtle, tiny variations in isotope ratios that appear only after careful study. Yet together, they tell a story of cycles, peaks, and sudden bursts of solar energy long before telescopes existed. Ancient trees that stood through medieval storms or more distant events carry these quiet records in their trunks, offering a stable, grounded counterpart to the sun's shifting rhythms. In their slow, patient growth, trees echo the same calm timing found in solar cycles, linking Earth's life to the long memory of the cosmos. The sun's magnetic flips happen on a predictable schedule, switching polarity every 11 years with a smoothness that belies the immense forces involved. As the solar cycle reaches its peak, the tangled magnetic fields reorganize themselves, slowly reversing north and south in a process that takes months to complete. From Earth, nothing dramatic appears. The sun looks the same to the naked eye, yet deep inside, vast currents of plasma are shifting, weaving new magnetic patterns that will shape the next cycle of flares and winds. This flip has happened countless times during the rise of early humans, during the age of mammoths, during the formation of ancient civilizations. Each reversal marks a new chapter in the sun's internal rhythm, guiding how energy will flow outward in the coming years. Even though the process is dynamic and full of motion, it unfolds with remarkable stability, reminding us that cosmic change can be steady, gentle, and deeply predictable. These magnetic flips guide long-term energy patterns around the sun, shaping how solar wind flows, where active regions form, and how strongly the corona releases its stored heat. After each reversal, the sun settles into a fresh arrangement of magnetic loops and open field pathways, establishing the structure that will govern space weather for the next decade. This new configuration is not abrupt. It emerges gradually as streams of plasma respond to the reorganized field, aligning into patterns that feel almost sculpted over centuries. These repeating changes create larger cycles that define eras of high and low solar activity, influencing auroras, atmospheric chemistry, and even subtle climate variations on Earth. Through all these shifts, the sun maintains a sense of calm continuity, an ancient clock marking time not with gears or numbers, but with gentle reorganization of its magnetic heart. Its patterns remind us that deep cosmic rhythms unfold slowly, quietly, and with an elegance that spans ages. And as these deep rhythms continue, they guide patterns far beyond the sun itself. Earth's climate gently responds to subtle solar variation, adjusting the way a lake's surface shifts under a faint change in wind. Even small differences in solar brightness, far too tiny for the human eye to notice, influence how heat is distributed through the atmosphere and oceans. These effects unfold slowly, over decades and centuries, shaping long-term patterns rather than daily weather. Slight increases in solar output can warm certain regions, while decreases allow cooler currents to emerge. Ice cores, sediment layers, and ancient ecological records all show this faint signature of the sun's shifting mood imprinted across Earth's history. Yet the changes are always measured. Never abrupt, the planet adapts gradually, absorbing each solar whisper into its larger climate rhythms. This gentle responsiveness reveals a deep, quiet bond between Earth and its star, one shaped not by dramatic changes, but by tiny, persistent variations that guide the planet's long environmental cycles. The Maunder minimum marked decades of unusually quiet sunlight, a period during the 17th century when sunspots nearly disappeared and the solar cycle seemed to fall into a long, slow exhale. During this time, solar activity dipped to levels lower than anything observed in the modern era, leaving a faint imprint on Earth's climate. Winters in parts of Europe grew colder, rivers froze more deeply, and historical accounts described pale, subdued skies. Yet, despite its impact, the Maunder minimum unfolded gently, without abrupt swings or violent changes. The sun simply settled into a quieter mode, maintaining a calm, low-energy rhythm for more than 60 years. Scientists now study this period through tree rings, ice cores, and early astronomical records, piecing together its serene but persistent influence. It stands as a reminder that the sun, like any natural system, experiences long phases of quiet that ripple through Earth's environment in slow, measured ways. The modern maximum brought a softer increase in solar activity, a centuries-long period when sunspots became more common and the sun's magnetic cycles grew slightly stronger. Starting in the early 20th century and lasting for several decades, this era produced more frequent flares and brighter auroral displays. Though always within safe and natural boundaries, the increase was gentle, not dramatic, a mild rise rather than a surge. Climate records from this period show subtle warming patterns that coincided with the sun's enhanced output, blending with other natural factors to shape modern climate trends. During these years, the sun seemed more expressive, sending a bit more light and energy into the solar system. Yet, even at its height, the modern maximum never broke the sun's long-term stability. It was simply another chapter in a much older rhythm, a reminder that the sun's variations unfold like tides, gradual, predictable, and part of a cycle millions of years in the making. Even powerful events like the Carrington storm of 1859 were temporary pulses, brief flashes of heightened energy within an otherwise calm pattern. The Carrington event stands as the strongest geomagnetic storm ever recorded in human history, producing auroras visible near the equator and causing telegraph lines to spark with unexpected currents. Yet, despite its intensity, the event passed quickly. Within days, the sun's magnetic field returned to its normal state, and Earth's systems adapted with surprising ease. What remains today are historical descriptions, traces in ice cores, and scientific models that help us understand how extreme but fleeting such moments truly are. The storm did not mark a long-term shift or disruption, but rather a single bright heartbeat in the sun's vast timeline. It reminds us that even the most dramatic solar events arise from natural processes that cleanly return to equilibrium, leaving space for the next cycle of quiet to unfold. Across billions of years, the sun has remained steady and calm, shining with remarkable consistency, while entire worlds formed, cooled, shifted, and changed around it. From the earliest days of Earth's molten surface to the rise of oceans, continents, and life itself, The sun has provided a stable flow of light and warmth. Its long cycles of activity have never wavered beyond safe bounds, allowing complex ecosystems to flourish and evolve. Geological records from ancient rocks to fossilized reefs trace this stability across unimaginable spans of time. Even as the sun's magnetic field flips, cycles rise and fall, auroras storms occur, its fundamental brightness remains nearly constant. This steadiness is the quiet foundation of life on Earth, a gentle assurance that the same star warming us today once shone upon the earliest microbes and will continue to shine for billions of years more. Through every age, the sun has been a calm, patient presence at the center of our cosmic home, and as these long rhythms unfold, gentle winds continue their journey. Solar wind travels for days before reaching Earth, drifting through space like a slow-moving river of charged particles, leaving the sun at hundreds of kilometers per second. The wind still needs time to cross the vast distance between star and planet. Along the way, it spreads out gently, its density thinning as it merges into the deep quiet of interplanetary space. This journey is smooth and calm, shaped by no atmosphere, no friction, only the sun's soft push guiding it outward. By the time the wind nears Earth, it has already passed countless magnetic eddies, crossed regions of changing plasma temperature, and blended into the wider solar breeze. Its arrival is not a sudden strike, but the end of a long drifting movement that began deep within the corona. Even when storms are involved, the journey remains slow and steady, reminding us that space weather unfolds on timescales far more patient than our own. Vast streams form when coronal holes open like wide gates in the sun's atmosphere, allowing plasma to escape more freely into space. These open regions, where magnetic field lines stretch outward instead of looping back, act as corridors for higher speed wind. Yet, even these fast streams do not feel violent. They simply flow more smoothly, carrying particles that have been gently accelerated by the sun's magnetic geometry. As the sun rotates, these streams sweep across the solar system in broad spirals, passing by planets and drifting through empty regions between them. When one of these streams reaches Earth, the magnetosphere subtly shifts, adjusting to the extra energy with a natural, practiced motion. The process remains calm, even elegant, like a soft breeze brushing against a window. These coronal holes, though dynamic in structure, produce wind that feels more like an open doorway than a forceful burst. Slow solar wind drifts from denser parts of the corona, forming a quieter, more measured flow that spreads through space like fog lifting from a warm surface. This wind is shaped by regions where magnetic fields curve back toward the sun, creating loops that gently constrain the plasma and release it in softer, slower waves. Because it moves more leisurely, the slow wind carries detailed impressions of the corona's temperature and structure, almost like an atmospheric fingerprint traveling outward for millions of kilometers. When it finally reaches Earth, it interacts with the magnetosphere in a calm, steady manner, producing subtle variations that blend easily into the planet's electromagnetic rhythm. The slow wind's journey highlights the peaceful side of space weather, a reminder that not all solar activity is fast or energetic. Much of it simply drifts, quietly filling the space between planets with gentle rivers of charged light. Interplanetary magnetic fields guide these flows, shaping the solar wind's path as it drifts across the solar system. These magnetic structures twist and spiral outward from the sun, forming patterns that resemble long, winding currents in a vast ocean. The wind follows these curves naturally, moving along invisible lines that keep its motion smooth and continuous. When the fields shift, the wind bends with them, adjusting its direction without breaking its rhythm. This guidance helps maintain stability throughout the solar system, ensuring that energy from the sun is distributed gradually rather than chaotically. By the time the wind reaches Earth, its path has been shaped by days of gentle steering from these interplanetary fields. The result is a calm arrival, part of a larger choreography that keeps the solar system balanced, even during periods of heightened activity. The wind remains tied to these magnetic pathways, moving in deliberate, graceful patterns. Solar wind creates a protective bubble around the solar system known as the heliosphere, a vast sphere of influence carved out by the sun's continuous outflow of plasma. This bubble shields the planets from a large portion of incoming cosmic rays, acting like a soft boundary where interstellar particles slow and disperse. The heliosphere expands and contracts over long cycles, breathing gently in response to the sun's magnetic activity. Inside it, the solar wind flows outward in smooth patterns, keeping the space around the planets relatively stable and quiet. At its distant edge, far beyond Pluto, the wind meets the interstellar medium and gradually fades into the background of the galaxy. This boundary, though created by charged particles, behaves more like a gentle cushion than a barrier. It shows how the sun, through nothing more than steady, drifting wind, protects its entire family of worlds with a calm, far-reaching touch. And as these long journeys unfold, the solar wind continues shaping the space between worlds. This protective bubble shields us from deeper cosmic radiation, softening harsh particles from the galaxy before they ever approach Earth. As solar wind flows outward, it creates a vast region where incoming cosmic rays are slowed, scattered, and weakened by the sun's magnetic influence. This means that most high-energy particles traveling through interstellar space never reach the inner planets at full strength. Instead, they brush against the heliosphere's boundary and lose momentum, dispersing into gentler currents long before they approach our world. The shielding is not rigid. It flexes and shifts over the solar cycle, expanding during periods of strong solar activity and contracting during quieter years. Yet through all these variations, it remains a stable cocoon surrounding the solar system. Even though we cannot see it, the heliosphere quietly protects every planet, moon, and drifting grain of dust within its reach, a soft, magnetic shelter shaped entirely by the sun's steady breath. The heliopause marks the sun's final whisper into space, a distant boundary where the solar wind slows to a stop and meets the interstellar medium. This transition is not a sharp line, but a gradual blending of two different environments, one shaped by the sun, the other by the wider galaxy. At the heliopause, the solar wind's strength fades into a gentle equilibrium, creating a region so calm that particles from the sun and particles from interstellar space drift together in near silence. It is the true outer edge of the sun's influence, the point where its protective bubble finally releases its hold. For billions of years, this boundary has drifted outward and inward, with the solar cycle always breathing slowly against the galaxy around it. Though unimaginably far away, the heliopause remains connected to us, a reminder that even the sun's most distant touch ends softly, merging into the vast quiet between stars. Voyager 1 crossed this boundary quietly, still listening as it drifted into interstellar space. After decades of traveling through the solar wind, the spacecraft entered a region where the sun's influence faded and the magnetic patterns around it became shaped by the galaxy itself. The transition was gentle, there was no shock, no sudden change, just a gradual shift in the particles and waves. Voyager detected. Its instruments recorded this passage with the same calm consistency that carried it across planets, moons, and empty regions of space. Now, far beyond the heliosphere, Voyager 1 continues to hear faint vibrations from distant cosmic processes, sending them back across billions of kilometers to Earth. Its journey is a quiet testimony to how softly the solar system blends into the interstellar environment. Even at this immense distance, the spacecraft moves through a peaceful realm shaped by slow, drifting currents of charged particles. Solar winds shape comet tails into long glowing streamers, gently pushing dust and ionized gas outward as comets travel around the sun. When a comet approaches the inner solar system, sunlight warms its icy surface, releasing vapor and tiny grains that become suspended in space. The solar wind then catches these particles, stretching them into luminous tails that always point away from the sun. These tails can extend millions of kilometers, forming smooth, sweeping arcs that glow softly against the darkness. Despite their size, the shaping force is subtle, a steady flow of charged particles guiding the comet's material into graceful patterns. The result is one of the most delicate sights in the solar system, a visible reminder of the sun's influence reaching far beyond the planets. Each glowing streamer carries the imprint of solar wind, drifting gently through space as the comet continues its long, elliptical path. Even at the edge of the solar system, the sun's breath remains gentle, spreading outward in thinning streams that eventually dissolve into the interstellar medium. Though the wind becomes faint at such distances, its presence can still be detected as a soft pressure, shaping the environment around the heliosphere. Here, the solar wind mingles slowly with cosmic particles drifting between the stars, forming a calm interface that marks the farthest reach of the sun's influence. Nothing dramatic occurs at this boundary, no sudden turbulence, no abrupt changes, only a smooth transition from one space to another. This gentle fading shows how persistent and patient the solar wind truly is, carrying the sun's magnetic fingerprint billions of kilometers from its surface. Even in these remote regions, the touch of our star remains soft, steady, and quietly protective. And within this breath, hidden patterns of magnetism quietly unfold. Magnetic loops rise from the sun's surface like glowing arches, forming some of the most elegant structures in the solar atmosphere. These loops are shaped by magnetic fields emerging from beneath the photosphere, lifting plasma upward in great arcs that can span thousands of kilometers. Despite the immense temperatures involved, the motion looks serene when observed through solar imaging, slow movements of light, following pathways carved by magnetism. Each loop carries a story of energy rising from deep within the sun, traveling outward before bending back toward the surface. They appear and disappear over hours or days, forming patterns that resemble celestial architecture. Even during active periods, their shapes remain graceful, curving naturally along magnetic lines that guide them like invisible rails. Watching these arches unfold is like witnessing the sun's heartbeat expressed through light, revealing the quiet beauty hidden inside processes far too large and powerful for the naked eye to sense. These magnetic loops hold plasma suspended in calm balance, creating pockets of glowing material that appear to hover effortlessly above the solar surface. The plasma trapped within them is incredibly hot. Yet, the magnetic fields form stable structures that keep it confined and gently supported. Inside the loops, charged particles follow curved magnetic lines, flowing in quiet, continuous paths, as if settling into a natural rhythm. From afar, these suspended shapes look almost weightless, drifting like lanterns tethered to unseen strings. Even during moments of increased solar activity, the loops sway and brighten in ways that feel smooth and measured. Their stability shows how magnetism and plasma can form a kind of cosmic harmony, with forces pushing and pulling in perfect balance. Through these structures, the sun expresses a softer side of its nature, not violent or chaotic, but poised, steady, and deeply beautiful. Filaments stretch across the sun like floating bridges, long threads of cool plasma held above the surface by magnetic fields. They can extend for hundreds of thousands of kilometers, forming dark, delicate lines against the bright solar disk. When viewed from above, despite their size, filaments move gently, drifting as the sun's rotation slowly carries them across its face. They are cooler than the surrounding corona, which is why they appear darker, yet they glow brilliantly when viewed from the side, becoming towering prominences that rise far into the sky of the sun. Their presence reveals the complex magnetic architecture beneath the solar surface fields, twisted and shaped into vast suspended structures that maintain their form for days or even weeks. Each filament is like a quiet bridge of plasma floating in a landscape of light, a reminder that even within the sun's dynamic atmosphere, there are moments of stillness and delicate formation. Prominences twist gracefully before gently fading, their immense arcs shaped by magnetic fields that guide the flow of plasma with exquisite precision. When viewed at the edge of the solar disk, these structures rise like glowing sculptures, slowly rotating and bending as the trapped material drifts along magnetic paths. Even when they erupt, the process often begins with soft movement, a slight lift, a gradual brightening, a slow unwinding of the structure. Many prominences simply dissolve, dispersing their plasma back into the corona without any dramatic release. Their graceful motions reveal how magnetism can create forms that feel almost organic, full of curves and gentle spirals that unfold over many hours. Watching a prominence evolve is like watching a slow dance in the sun's atmosphere, one shaped by forces beyond human scale, yet expressed with surprising elegance and calm. The chromosphere's pink glow is sunlight filtered through hydrogen, producing one of the quietest and most beautiful layers of the sun. During eclipses, this thin region appears as a soft reddish ring around the darkened disk, glowing with a light that seems both delicate and ancient. The color comes from hydrogen atoms absorbing and releasing energy in a narrow wavelength known as H-alpha, creating the gentle pink tone that astronomers study to understand solar activity. In this layer, spicules rise like fine grasses in a cosmic meadow, carrying plasma upward in motions that last only minutes, yet unfold with remarkable smoothness. The chromosphere sits between the bright photosphere and the hotter corona, bridging them with a blend of color and motion that feels almost meditative. Its glow is a reminder that even within a star's turbulent atmosphere, there are layers where light moves softly, filtered through simple atomic processes that have shaped solar beauty for billions of years. And within these magnetic shapes, deeper patterns continue to unfold. Coronal rain falls in slow, glowing droplets of plasma, descending gracefully along magnetic loops that arch high above the sun's surface. This rain forms when hot plasma in the corona cools just enough to condense creating bright beads that follow curved magnetic paths downward. Each droplet travels at great speeds, yet from a distance, the motion appears tranquil, like tiny lanterns drifting along invisible rails. As they fall, the droplets sometimes fragment into smaller threads, shimmering softly before dissolving back into the solar atmosphere. This gentle cycle of heating, cooling, and falling repeats across many regions of the Sun, revealing a quiet interplay between temperature and magnetism. Though the corona is millions of degrees hot, its rain behaves with surprising delicacy, painting faint streaks of light that move in slow harmony. It's one of the Sun's most intimate displays, a reminder that even in extreme environments, beauty often emerges in calm, drifting motion. Magnetic carpets cover the Sun's surface in tiny organized cells, each one shaped by small-scale magnetic fields rising from the interior. These cells form a dynamic mosaic that continually shifts and rearranges itself. Though the overall pattern remains remarkably ordered, the borders between cells guide flows of plasma, creating narrow channels where bright, thin structures appear and fade. From afar, the carpet looks like a textured fabric woven from light, each patch holding a slightly different magnetic polarity. These small features may last only minutes or hours, but together they maintain the Sun's quiet background activity, the subtle hum beneath larger solar events. Their motion is smooth and coordinated, never chaotic, reflecting the underlying organization of the Sun's magnetic engine. This delicate cellular structure helps regulate the corona above and influences how energy rises through the solar atmosphere, revealing that even the Sun's most complex behavior begins with simple patterns stitched across its surface. Sunspot groups rotate in quiet choreography, moving with the Sun's slow 27-day spin. These dark regions, formed where magnetic fields strengthen and cool the surface, drift across the disk like clusters of shadowed islands. Their motion feels calm and deliberate, guided by the Sun's internal currents. As sunspot groups evolve, their magnetic shapes twist gently, forming new patterns that rise, merge, or fade over days. Though they often herald stronger solar activity, their behavior is not violent. It is structured, rhythmic, and deeply connected to the Sun's internal cycle. Watching a sunspot cluster move is like observing the gears of a cosmic clock turning beneath the surface. Each rotation carries them toward the limb, where their edges shine with bright magnetic loops arching upward. Their choreography reveals the Sun's hidden dynamics, transforming complex magnetic interactions into slow, graceful motion. Magnetic reconnection releases energy softly upward, reshaping the corona through smooth, flowing transitions rather than abrupt bursts. When magnetic field lines realign, they create pathways for plasma to accelerate, heating the surrounding atmosphere in gentle pulses. Though reconnection is a powerful physical process, much of it unfolds with calm, controlled movement, loops shifting, arches stretching, and threads of plasma rising like warm air currents. These upward flows spread through the corona, illuminating regions that were quiet moments before. Even during larger events like flares, the early stages of reconnection begin with subtle changes, small brightenings, slight motions, and gradual rearrangements that build into larger structures. This process shows how the Sun converts magnetic tension into light and heat through mechanisms that are as elegant as they are fundamental. Beneath all visible activity lies this quiet, reshaping, a whisper of energy drifting upward through the solar atmosphere. Even the most complex solar storms begin with simple magnetic motion, subtle twists and bends in the sun's magnetic field that slowly accumulate over time. These early movements are often too gentle to detect without specialized instruments. A slight distortion in a magnetic loop, a quiet buildup of tension beneath the surface, or a small shift in plasma flow. Yet these minor adjustments set the stage for larger events, guiding how energy will rise, merge, or release as the sun rotates. These magnetic patterns interact, forming structures that may eventually lead to flares or coronal mass ejections. But at their origin, the motions are calm, part of the sun's natural rhythm, unfolding at the pace of its internal cycles. This simplicity at the heart of complexity reveals the sun's true character, a star whose most impressive displays begin with tiny, patient steps. Each storm is simply a larger echo of these quiet, ancient motions, and under this ancient star, life on Earth continues its gentle rhythm. Sunlight nourishes plants through photosynthesis, a gentle process that has shaped life on Earth for billions of years. When sunlight reaches a leaf, it does not rush or force its way in. It is absorbed softly by pigments that turn its energy into food, growth, and oxygen. This quiet transformation supports every ecosystem on the planet, linking forests, oceans, grasses, and microbes to a single warm source above. Even the air we breathe carries the imprint of this ancient partnership between sunlight and life. Through each sunrise and sunset, the world renews this connection, repeating a cycle so steady that it becomes the heartbeat of every landscape. In this way, the sun nourishes not just individual plants, but the delicate balance of the entire biosphere, giving Earth a sense of continuity that stretches across ages. Its light falls evenly across continents and oceans, reminding us that life here has always grown under the same calm, patient star. Solar energy warms oceans in cycles older than humanity, guiding currents and patterns that have shaped climate since long before the first humans walked the Earth. Sunlight penetrates the surface waters, heating them gently, and this warmth slowly spreads through layers of the sea, creating vast circulations that move like slow, planetary tides. These motions regulate weather, nourish marine life, and support ecosystems that stretch from coral reefs to polar shelves. Even small variations in solar energy cause long-term changes in the rhythm of the oceans, influencing everything from monsoons to deep-sea nutrient cycles. Yet through all these effects, the process unfolds gradually, with sunlight interacting softly with water that has flowed across Earth for millions of years. The oceans respond with calm inertia, absorbing and releasing heat in patterns that feel almost timeless. This slow, steady exchange is one of the reasons our planet remains stable, carrying the sun's warmth with the gentleness of a cradle. Circadian rhythms sync with the sun's daily rise, aligning the internal clocks of living organisms with the soft pattern of day and night. From the opening of flowers at dawn to the quiet rest of animals at night, life on Earth has evolved to follow the sun's gentle cycles. In humans, sunlight nudges hormones, temperature, and alertness, guiding the body into a natural rhythm that repeats every 24 hours. Even brief moments of morning light can help reset this internal clock, bringing the mind and body into balance. These rhythms are so deeply rooted that they remain active even when sunlight is scarce, carrying an echo of the day within us. The daily return of light provides a sense of stability, reminding us that the sun's steady presence governs not only the movement of planets but also the quiet patterns of sleep, energy, and growth. This connection between sunlight and biological time makes life feel anchored, predictable, and gently supported. Every living thing carries a memory of sunlight, encoded in the evolutionary history that stretches back to Earth's earliest organisms. The first life forms emerged in a world shaped by solar energy, learning to use light as a source of warmth, fuel, direction, or time over billions of years. That memory became woven into biology itself in chemical pathways, genetic responses, and behaviors that all depend on light in some way. Plants remember sunlight in the way their leaves tilt and turn. Animals remember it in their migration patterns, breeding cycles, and seasonal rhythms. Even humans carry this memory in emotions that shift with the seasons, in the sense of renewal at each sunrise, and in the calm that comes as daylight fades. This deep connection makes sunlight feel familiar, comforting, and essential. It is more than energy. It is history woven into living cells, a quiet legacy of the star that has guided Earth since the beginning. Solar storms subtly enrich Earth's upper atmosphere, adding energy that helps create new ions and influences the composition of the ionosphere. When gentle streams of charged particles arrive, they interact with atmospheric gases, forming layers that support communication signals and reflect radio waves across long distances. These changes do not disturb the planet's surface. They unfold high above in thin, quiet regions of air, to far removed from the daily life below. Even during stronger storms, the energy enters in smooth waves, enhancing the atmosphere's ability to conduct and transmit signals. This subtle enrichment has occurred for millions of years, shaping the upper sky in soft, repeating cycles. While the auroras are the most visible expression of this process, much of the interaction remains invisible, a delicate exchange that strengthens Earth's electromagnetic environment. It is one more way the sun influences our world with a calm, nurturing touch. And under this quiet sun, life continues to follow its gentle rhythm. The ionosphere reflects radio waves that circle the world, creating a silent pathway in the upper atmosphere that allows signals to bend and travel far beyond the horizon. When radio waves reach this charged layer of air, they bounce softly between Earth's surface and the sky, forming gentle loops that can span continents. This process happens continuously, day and night, adjusting quietly with solar activity. During calm periods, the ionosphere becomes a smooth mirror, guiding signals with remarkable steadiness. During more active periods, it shifts slightly, reshaping the height and density of its layers without disrupting the harmony of the waves. Long before satellites existed, this natural reflector connected distant regions of the planet through invisible threads of communication. Even today, it remains an essential part of Earth's electromagnetic environment, a quiet intermediary between sunlight, charged particles, and the technologies that bind the modern world together. Migrating animals navigate using Earth's magnetic field, responding to gentle cues that guide them across oceans, continents, and seasons. Birds sense subtle variations in the magnetic lines around them, allowing them to travel thousands of kilometers with astonishing accuracy. Sea turtles rely on magnetic signatures imprinted in their memory, returning to the same beaches where they were born. Even tiny insects follow magnetic patterns, moving along paths shaped by forces the human senses cannot perceive. These abilities evolved over millions of years under a steady sun whose calm output keeps Earth's magnetic shield stable enough for life to rely on. The migrations unfold slowly, tied to temperature, daylight, and instinct, a long, flowing dance connecting generations of creatures to the planet's quiet magnetic rhythms. Each journey is a reminder that life is deeply attuned to the invisible structure surrounding Earth, and that magnetism acts as a soft, the reliable compass for countless species. Human bodies react gently to electromagnetic changes, adjusting internal rhythms in ways that are subtle and often unnoticed. Variations in sunlight influence hormones tied to sleep and alertness, while shifts in geomagnetic conditions can affect mood, focus, or patterns of rest. These responses are not abrupt. They unfold smoothly across hours or days as the body adapts to changes in its environment. Our nervous systems, shaped by millions of years of evolution under a stable sun, are tuned to the quiet patterns of light and magnetic flow that move through the atmosphere. Even during solar storms, the effects on the human body tend to be soft and gradual, blending into the natural fluctuations of daily life. This gentle sensitivity is part of our connection to the Earth-Sun system, a subtle reminder that we are not separate from the cosmic conditions around us, but quietly shaped by them in ways woven deep into our biology. The sun's stability makes long-term life possible, offering a nearly constant flow of light and warmth that has remained steady for billions of years. Unlike many stars that flare unpredictably or dim dramatically, our sun maintains a calm brightness that allows ecosystems to flourish without sudden changes. This reliability is the foundation upon which oceans, climates, and entire food webs have evolved. The slow rise and fall of solar cycles shape Earth's environment in gentle waves, giving life time to adapt and develop intricate patterns of behavior and growth. Through ancient extinctions, changing atmospheres, and shifting continents, the sun has remained a steady presence. Its consistency provides the backdrop for evolution itself, enabling life to expand, transition, and diversify over unimaginable spans of time. Without this calm star, the delicate balance of Earth's environment could not exist, and neither could the long, unbroken story of life. Its calm output supports Earth's climate and seasons, creating dependable cycles that shape agriculture, migration, and the rhythms of everyday life. The balance between sunlight and the planet's rotation brings predictable temperature shifts, allowing plants to grow in stable patterns and animals to follow seasonal cues. Even small changes in sunlight distribution gently influence rainfall, wind, and ocean currents, weaving together a climate system that has supported life for ages. The sun's energy reaches Earth with remarkable steadiness, never spiking or fading beyond what ecosystems can handle. This constancy allows forests to rise, deserts to breathe, oceans to circulate, and glaciers to form slowly over time. It is this soft reliability, the quiet delivery of light across each year, that gives Earth its harmony. Every sunrise continues a pattern older than mountains, shaping seasons that return with patient regularity. And so, the dance between Earth and Sun continues into the future. Earth orbits the Sun in a slow, elliptical rhythm, moving through space with a steadiness that feels almost meditative. This path is not a perfect circle, but a gentle oval, shaped by gravitational balances that have remained stable for billions of years. As Earth travels along this curve, The seasons unfold in their familiar progression, each one a soft marker of our changing position in the great cosmic loop. The orbit also controls the length of days, the angle of sunlight, and the rhythm of climate systems that guide life across the planet. From space, Earth's motion looks effortless, a smooth glide through a quiet, sunlit Zia. This slow journey ties every living thing to the same celestial heartbeat, a rhythm carried through generations without ever breaking stride. The orbit is more than a path. It is Earth's long inhale and exhale, a continuous flow that shapes time, light, and the gentle conditions that make life possible. Solar storms sweep past like passing tides, rising and falling with a natural rhythm that mirrors the breathing of the sun. When streams of charged particles reach Earth, they move in smooth waves that wash over the magnetosphere, bending and flowing around the planet without disturbing the surface below. These storms are not constant. They come in cycles shaped by the sun's activity, arriving with a softness that belies the vast energies involved. Each one adds a little pulse of heat and motion to the upper atmosphere, then fades as the solar wind returns to its quieter state. Over centuries, these tidal patterns have repeated again and again, leaving subtle traces in ice, magnetic records, and the shimmering glow of auroras. To Earth, they feel like distant weather, brief cosmic breezes from a star that remains calm at its core. In their gentleness, they remind us that even powerful forces can move with grace. Auroras mark the boundary where Earth meets space, glowing softly at the edges of our atmosphere as solar particles drift into magnetic pathways. These lights are more than a visual display. They are the signature of Earth's connection to the sun, a visible thread linking our world to the wider cosmos. When electrons spiral downward, they illuminate the sky in hues of green, red, and violet, forming curtains of light that ripple like silk. These boundaries shift gently as the solar wind changes, expanding during active periods and settling back during calmer times. From the ground, the aurora feels peaceful, a reminder that even at the frontier between Earth and space, the interaction is smooth and balanced. This glowing edge marks the meeting point of two vast systems, Earth's protective shield and the sun's drifting particles, both moving together in a dance older than human memory, unfolding silently above the world. Magnetic storms reveal the unseen structure of Earth's shield, lighting up patterns in the magnetosphere that normally remain invisible. When solar energy enters this protective field, it highlights the lines and curves that guide charged particles around the planet. Instruments detect these motions as subtle shifts, waves, bends, and gentle reconfigurations that echo through the magnetic environment. Though they may sound dramatic, magnetic storms unfold in calm stages. Energy builds, flows outward, and then slowly disperses. These events help scientists map the magnetic field's architecture, showing how it stretches like a protective shell around Earth. For life on the surface, the shield continues its quiet work, deflecting most of the incoming particles long before they approach the atmosphere. Magnetic storms are simply moments when this hidden structure briefly becomes more expressive, revealing the elegant geometry that keeps Earth safe. In their patterns, we see the quiet strength of a planet shaped by cosmic forces. Even quiet days carry gentle solar energy, delivering a steady stream of light and warmth that nourishes every part of Earth. On the calmest days, the sun's output feels almost still a soft, even glow that settles across oceans, forests, mountains, and cities. This constant energy supports climate cycles, drives winds, fuels photosynthesis, and keeps temperatures within the range that life depends on. Quiet solar days are the backdrop for nearly all of Earth's history, far outweighing the brief moments of storms or heightened activity. They form the long, unbroken thread of warmth that has carried life from its earliest origins to the present. Each sunrise renews this gentle flow, reminding us that Earth's relationship with the sun is not defined by dramatic events, but by the persistent calm in between. In that steadiness, our planet finds balance, a quiet partnership with its star that shapes every moment of daylight. And so, the dance between Earth and Sun continues into the future. Earth's tilt shapes sunlight into 4 calming seasons, giving the planet a slow and gentle rhythm that repeats each year with perfect consistency. As Earth leans slightly on its axis, different regions receive more or less sunlight, creating cycles of warmth, growth, rest, and renewal. These changes happen gradually, allowing plants, animals, and entire ecosystems to adjust in soft, natural steps. Spring brings lengthening days and gentle light. Summer unfolds in warm arcs. Autumn cools the air in slow fading tones, and winter settles into quiet stillness. This tilt is small, just over 23 degrees, yet it guides everything from the blooming of flowers to the migration of birds. It shapes cultures, calendars, and the sense of time itself. Without it, Earth would be uniform, lacking the comforting rise and fall of seasonal change. With it, we experience a world that breathes in broad, peaceful cycles, echoing the calm precision of our orbit around the sun. Solstices mark the deepest points of the sun's yearly arc, moments when sunlight reaches its farthest extremes in the sky. At the summer solstice, the sun climbs to its highest path, stretching daylight into long golden hours that feel warm and expansive. At the winter solstice, its arc dips low, creating shorter days filled with softer, more diffused light. These turning points arrive quietly, without fanfare, yet they have guided human rituals, agricultural cycles, and cultural traditions for thousands of years. Each solstice acts as a gentle hinge in the year, signaling a shift in the balance of light and shadow. Nature responds slowly. Birds change their songs, plants alter their growth, and entire landscapes transition in harmony with the sun's position. The solstices remind us that even the largest cycles in the cosmos have soft edges, unfolding with patience and clarity, shaping time in a way that feels both ancient and reassuring. Equinoxes balance day and night perfectly, offering 2 moments each year when sunlight divides the world into equal halves. During an equinox, Earth's tilt aligns so that every place on the planet receives nearly the same duration of daylight and darkness. This balance gives the equinoxes a quiet sense of symmetry, a brief pause in the shifting rhythm of seasons. The light arrives evenly, neither too strong nor too weak, and the transition from one half of the year to the next feels especially smooth. Plants respond by shifting growth patterns. Animals adjust their behaviors, and humans often experience a subtle sense of renewal. These balanced days have inspired myths, calendars, and celebrations across cultures, marking moments of harmony between Earth and Sun. Though the equinoxes pass quickly, their calm equilibrium lingers, reminding us that the planet's long journey through space is filled with gentle moments of perfect alignment. The Sun and Earth have moved together for 4.5 billion years, sharing a partnership that began long before oceans formed or continents settled into place. From the earliest molten landscapes to the first breaths of life, Earth has circled the Sun in steady, repeating loops, guided by gravity and shaped by time through meteoric impacts, shifting climates, ice ages, and warm periods. The Sun's presence has remained constant, a quiet guardian, shining with remarkable stability. This long companionship allowed life to evolve, diversify, and flourish under dependable cycles of light and warmth. Every generation that has ever lived has risen and rested under the same star, following the same ancient rhythm. The Sun's gravity holds Earth gently in its orbit, while Earth's rotation turns sunlight into day and night. Together they form a cosmic duet, a slow, enduring pattern that continues to shape the planet's environment and the lives upon it. And every night, this ancient connection continues as you rest, carrying its calmness into your quiet moments. Even while you sleep, Earth keeps moving along its path, turning steadily toward the next sunrise. The Sun's gentle energy still flows across space, brushing the atmosphere, guiding the seas, and maintaining the rhythms that support all living things. You lie beneath this vast clockwork, breathing in sync with cycles older than mountains, older than oceans, older than life itself. The night does not break the connection, it simply softens it, wrapping the world in cooler tones while the sun waits beyond the horizon. This continuity brings comfort, a reminder that the same forces that shaped ancient forests, early oceans, and entire eras of life are still moving with you, around you, and through you. In this quiet bond, the universe feels close, steady, and deeply peaceful. And now, with these 100 quiet truths, your breathing softens. As we come to the end of our journey tonight, let yourself settle into the quiet space you've created. You've drifted through magnetic fields, ancient rhythms, glowing auroras, and the slow breath of the sun itself. You've followed the long arc of light from the solar core to Earth's sky, watched storms unfold like distant tides, and felt the deep calm of the cosmic cycles that guide our world. All of these patterns, from the soft rise of seasons to the gentle shifting of solar wind, remind us that the universe is not in a hurry. It moves in broad, patient motions, repeating shapes and rhythms that have endured for billions of years. And in that enormous stillness, you are held. Tonight, you rested beneath the same star that warmed the first forests, the early oceans, and every generation before us. The sunlight you felt today traveled for millions of years inside the sun before breaking free into space, crossing 150 million kilometers to touch your skin. That warm glow carries the history of the entire solar system. It carries the memory of ancient storms, magnetic flips, coronal rain, and the steady cycles that shaped life on Earth. When you breathe, you're breathing in a world sculpted by those quiet forces, a world whose every mountain, tide, and heartbeat has unfolded under the sun's steady watch. As your thoughts slow, imagine Earth moving gently through its orbit, gliding along its elliptical path with the softness of a boat drifting across a calm sea. You don't have to feel the motion for it to shape you. Every day, the planet turns you toward the morning, toward warmth, towards light. Every night, it turns you toward rest toward the cooler, quieter side of the world, where the atmosphere settles and the sky opens for stars. These daily and yearly rhythms have held life in balance for ages, creating the seasons, guiding migrations, shaping forests, and supporting the quiet choreography of nature. And somewhere far above the atmosphere, auroras continue their slow dance, even while you sleep. Arcs of green and red drift across polar skies, tracing the invisible boundary where Earth touches space. Magnetic currents bend and sway, solar particles spiral, and the planet's shield flexes with ancient grace. All of it happens silently, softly, in the wide stillness of the night. You are part of that same calm system, one tiny but essential piece of a cosmic pattern that has repeated itself for longer than memory. Let yourself feel the safety of this connection. Feel how steady the sun is, how faithfully it rises, how gently it warms, how patiently it carries the solar system through interstellar space. Feel how deeply Earth protects you, wrapped in its magnetic cocoon, breathing in sunlight and exhaling auroras. You live in a world balanced between these two great forces, the warmth of the sun and the shelter of the planet, a world that has supported life for billions of years and will continue to do so long after tonight. If your mind drifts, let it drift the way solar wind drifts, slowly, gracefully, without pressure. If a thought appears, let it pass, like a comet tail glowing softly against the dark. There is nothing to solve now, nothing to reach for, nothing to carry, just breath and light and the quiet rhythm of the universe moving around you. As you fall asleep, remember this: you are resting under the same sky that has guided sailors, nourished forests, shaped oceans, and lit the aurora for countless generations. The same sun that warms the mountaintops and paints the clouds gold at sunrise is watching over you tonight. You are part of something ancient, peaceful, and endlessly beautiful. Sleep well under the same sky that connects us to every star we visited tonight. Good night,